All right, yes. Thank you very much, and thank you everyone for coming. Yeah, as Cameron was saying, I've been to BUIDL Asia quite a long time. I think ever since actually BUIDL Asia got started back in 2017, 2018. And it's always a pleasure to be back in Korea. To me, it's still one of the funnest cities I think you can be in. Okay, so today I will very briefly talk about the Anoma DOS that gives you really privacy everywhere. And the DOS here stands for Distributed Operating System. And I will start off with a very brief analogy of what the Anoma DOS actually is. It is the Windows 95 moment, but for blockchains, where rather than having many different systems that you each need to program against, you have one operating system at a high level of abstraction that runs wherever you want it to run. So for example, the Anoma DOS currently runs on Ethereum, it also runs on BNB Smart Chain, it also runs on Solana, and sort of any chain in the future, whether this is an enterprise chain or a public blockchain, you can just build and deploy the Anoma DOS to, and then all applications that were written against the operating system will also run wherever the operating system actually runs. So it's kind of like, instead of building an application against a specific microarchitecture, against a specific chip, you build an application against Windows, and then your application also runs wherever Windows runs. I'll give you a little bit of background, mostly because I like the image of the Swiss flag. Yeah, so Anoma was founded in 2021 in Zug because I happen to live in Zug because it was the safest place on earth I could imagine, and I thought the US dollar was about to collapse in 2018. Mea culpa, I may have been slightly early, even though probably not wrong. It's a team of 30 people from all over the world, and we've been involved in a lot of different projects. Ethereum, Cosmos, Polkadot. We ran a bunch of early validators across networks. And really, we figured out that the core competency needed for an actual blockchain to win, or an actual system to win, was you needed a very strong background in distributed systems, cryptography, and compilers. And actually, it's important that you have a background in all three, because blockchains are generally made up of these three components, especially when it comes to allowing developers to build actual applications in ZK. So yeah, why Anoma? Well, in 2020, 2021, it was a very weird time in blockchains, in my opinion, because everyone was copying the same 3 smart contracts and putting them yet onto another EVM chain, and for some reason this was supposed to be progress, right? And like, we had all these clones appearing, and sort of from a very fundamental developer perspective, they didn't actually allow me to do anything interesting, anything novel, anything new. And so the sort of fundamental problems that we identified with Anoma was, A, we needed privacy, and we needed privacy with a base layer having thought about this, so that it's easy to write privacy-preserving applications, and we're finally getting there. So with Anoma, you get full privacy-preserving application programmability. The second component was you needed a way to do counterparty discovery, i.e., most of these systems were designed really around the idea of you have a bunch of global state in the middle, and then users would all coordinate via this global state in the middle, for example, the global state of Ethereum. In reality, though, this is very unlikely to actually work in practice because A, it is much easier for me to find someone in this room that I would like to, for example, trade with rather than going via some global database. And B, for privacy-preserving applications specifically, it is really, the model is different because with privacy-preserving applications or ZK applications, the state doesn't live in the middle of the chain anymore. It lives on the edges, so it lives on edge devices. And so with Anoma and Anoma Intents, this models actually the sort of movement of the state towards the edges of a network rather than the center of the network. And then the third area, which was really like one of the founding principles, was there were going to be thousands of chains. And you wanted to have the ability to have a homogeneous architecture so that we don't all have to rewrite all our applications all the time, but in a heterogeneous security environment where, for example, Hyundai in South Korea can run an enterprise chain, but my application can roam between the Hyundai chain and public Ethereum, for example. Yeah, so blockchains, generally speaking, are full of structural problems. And Anoma is this very ambitious task to address a lot of these structural problems head on. And the structural problems, and I already mentioned them a little bit here, they are fundamentally around privacy, so transaction data being publicly readable by everyone by default. And Ko was talking about this earlier. it's going to be a fundamental problem. Like no real human being is going to use these chains at scale if their entire data is public to the world. This sort of starts at the micro level of like, I don't think my parents would be all too happy if their neighbors know how much monthly income they have or whether they've just been to the doctor. And on the other side, it's also, as humans, we are very susceptible to algorithmic pricing. And by having a lot of financial trails behind you transparently, you actually are much worse off with regards to algorithmic pricing. This problem is even worse for agents. Like if you want to have your agent, which Anoma's intends support, sort of like negotiate, for example, a flight ticket on your behalf. One of the big problems is if the actual offerer of flight tickets can see that you regularly spend thousands of dollars and you have tens of thousands of dollars in your bank account, they will obviously give you a higher price. So with agentic payments, we are just creating more and more metadata, and having privacy given all of this metadata, it's very fundamentally important if we want the space to actually work in practice. The other one is interop. It is very strange at the moment that I actually have to like install, that there's like an AMM on Ethereum and an AMM on BNB, for example, and an AMM on NIA and an AMM on Solana, and they're all different. Really from a user perspective, I just want to have the ability to exchange some funds. I don't really care that they are like that this one is green and the other one is blue. I just want to have the ability to roam with my application so that I can use the same interfaces everywhere. One of the good examples actually of an interface that roams really well are mobile phones. I bought my phone in Switzerland and it still works in South Korea. It's amazing. But currently in blockchain terms, you're really living in this world where every single chain you go to, you have to buy a new phone. In order for like, if you want to be in South Korea and have connectivity, I'd have to buy a new phone. This is sort of the reality we're currently living in with blockchains. And the last one is scale. And here I always like to jokingly say that Anoma can be as decentralized as Bitcoin or more and faster than Solana or faster. Because fundamentally Anoma is not a specific chain, it is rather an architecture that allows you to, like you can configure how you'd like to deploy it. I.e. you can deploy it with more validators, more nodes than Bitcoin. You can deploy it on a single really beefy server, so it's faster than Solana, and everything in between. Because I think this is the important thing. Like scale and security is not really, it's not a black and white thing. It's like different people have different preferences. And for example, some people want really fast trading capabilities. If you want really fast trading capabilities, you're going to necessarily trade off with regards to decentralization. If you want really strong decentralization, your consensus times are going to be slower. And maybe the last bit actually I mentioned here on the scale part is that one of the really important points is with regards to trading is that not everything has to be globally totally ordered. I.e., if in this room we just want to do some coffee payments, there's no reason to order these coffee payments next to the coffee payments in New York. But at the moment, we're all living in this world where we're paying for the cost of total global order, and we're taking the latency hit essentially because we have to do a bunch of world round trips in order to get global consensus. Whereas if you actually just want to do fast settlement for coffee payments in this room, we should just do it locally. So you should always be as local as possible and as globally interconnected as required. And if you want to find me afterwards and talk about World War III and why this is also a good idea in the case of fiber cables go away, yeah, just come find me afterwards. This is too much for this talk. Yeah, just the patches to the problems we currently have, with privacy, it's still very, very patchy. Essentially, we have specific assets. The huge problems are that you have to have specific assets, and most people don't really give a shit about ZEC or XRM. I want privacy for USDC and USDC transfers or my housing NFT. With the interop thing, we sort of picked the choice of centralized multisigs. And with scale, essentially, we picked the choice around having a one world chain. I.e., we're all trying to compete in oh, who's going to be the globally most dominant chain rather than having many different chains that can have various security models. Right, I'll give you actually two very concrete examples around why interoperability really matters and why complex interoperability matters. So currently we have interoperability that allows you to move assets between chains, which is very cool. I can move some ETH between chain A and B, and I'll bracket the problem of security model for now, but generally I can move assets around. The problem is, the moment I have complex state, and this, for example, I always like to use the example of a maker CDP. A maker CDP is a complex piece of state. An LP position in a Uniswap pool is also a complex piece of state. I cannot move the complex piece of state around. With Anoma, you can. That you can essentially move complex pieces of state between two different systems. Where rather than, for example, in the case of a Uniswap LP position, having to unwind your LP position to then recreate it on the other side, you can just directly move your LP position. And then in the example for privacy here, at the moment you have to essentially like move Zcash, like sell your assets, buy some ZEC, buy some XIM. But here you split your privacy model, you split your shielded set, and sort of fundamentally, it's a terrible UX from a usability perspective. Like one cool thing that I did yesterday with Anoma Pay actually is I needed to buy a SIM card here, and I was in my hotel room and I didn't want to leave the room, so I just bought a digital SIM card. And one of the big problems as well, how did I pay for it? Well, I actually ended up just using Anoma Pay to privately send some SOL to that service because I didn't also want to dox all my other activities to that service. And I really didn't want to have to spin up a bunch of new seed phrases again and do all that shebang. So what's the solution here? Well, we have a couple of choices. We could just keep going with where we are. I mean, we do these monkey patches, we accept a fair bit of centralization, we accept fragmentation and bad UX, and I would honestly argue that if we don't actually solve these three problems, we will most likely make these systems a novelty over the long term that will get co-opted by the institutions to just essentially be a slightly faster way of banks to settle interbanks, on an interbank level. And at least when I joined crypto, I didn't join crypto to we do slightly Web 2.1. I thought if we actually tried to fix these problems, we can actually build a true Web 3.0 that's actually going to be very cool to use for ordinary people. And a fun aside here, I think there's a strong reason why we actually will need this, because every year sort of the UX of Web 2 goes down, because it's when I tried to buy the SIM card via my Swiss provider, and they were like, oh, come to the office to sign up for this new SIM card. I was like, well, I'm 20 hours away, and I need it only for the next 5 days. It's not going to work. And so with Web 3 and privacy guarantees and services built around Web 3, we have this ability to actually build much better UX than we have currently in Web 2. So yeah, we can challenge the status quo. We can break free from blockchains. We can architect the infrastructure from first principles so that we're not relying on this model of there's a single chain to rule them all, or none of these chains really have native interoperability, but rather we can have this operating system abstraction sitting on top of all these different systems so that we can have a nice UX and developer experience. And so some non-negotiable properties are good user experience, privacy, interoperability, scalability, and most importantly, sovereignty. And I would actually argue that sort of for real-world adoption, sovereignty is going to be a really big problem, where most nation states aren't going to give up the monetary authority to the Ethereum validator set. They will want something where they have their own sovereignty. And I think the big trick for us as an industry is how do we make those sovereign systems interoperable with the public systems we're working on? Yeah, so this comes to Anoma, the distributed operating system. Before we had operating systems, we already had computers, and programming computers kind of sucked because you program it against a specific microcontroller architecture. And this meant your program was A, difficult to write, and B, non-portable. Yeah, so you need to be an expert essentially. And as a result, we didn't get that many programs, realistically speaking. After we started having operating systems, computers actually became pretty fun. And to me, a computer will always sort of be like this operating system on the left, because it's the first operating system that I used in practice when I was a child. And so I kind of wish that things would actually still work this way and load that snappingly fast. It was good back then. But with operating systems, we actually got to a point where normal people could start developing applications. They could also those applications could also run independently of the hardware. It just mattered that like Windows was implemented for that specific chipset, and then the applications could run wherever Windows essentially ran. So like we got essentially system calls as a high-level abstraction that we could play with. So applications were no longer machine-specific. And programming applications didn't really require a ton of in-depth knowledge about the underlying hardware. So this is generally how this looked, and this is how this looks with a DOS. So that we have blockchains, and here blockchains are the underlying hardware. So for example, currently the DOS is deployed on Near, on Solana, on Ethereum, BNB, Arbitrum, Base, essentially every major system that you can think of. And on top of the DOS, you have applications, and the nice thing is you don't have to rewrite your application for the different for different deployments of the operating system. So for example, with Anoma Pay, we have it working, the same application works on Solana as it does on BNB Smart Chain, as does on Ethereum. And we didn't have to change the application. So just imagine, rather than having to write both EVM code as well as SVM code, you just write code once and it just works everywhere. Yeah, you get one unified interface. Using blockchains doesn't feel like using 5,000 different chains anymore. And developers can build up an application once, they work everywhere, and at that point you can just focus on PMF. Yeah, this is roughly how this looks. So at the bottom you have an infrastructure layer of blockchains and service providers, and these could be centralized chains, enterprise chains, public chains, you name it. On top, in the middle, you have a networking layer that hooks up all these systems together, and then on top you have the application layer that developers actually build and users actually use. Yeah, and then the hardware layer is just this. And with this, really every chain becomes at your command. The cool thing is, Anoma is live. So yeah, the Anoma DOS is installed via protocol adapters, which are essentially implementations of the operating system. They're all open source. So it's live on Ethereum, Arbitrum, Base, Near. We have the protocol adapters of the operating system working on Solana. So if you're a developer in the room, you can just play with it today. And actually, if you want to see some of the activity, you can go to explore.anoma.net and just check it out. One of the very cool things here is that you, with Anoma as the DOS, because we thought about privacy as a first-class primitive, you just get programmable privacy by default. So rather than having to fight the base layer that you want to work with to like add you the right opcodes, like with Anoma, you can just build privacy-preserving applications, both in terms of data privacy as well as function privacy from the get-go. So wherever you want to build your application, because many different people have different sort of preferences, requirements, if you use Anoma here, you can just get private applications even if the base system doesn't support privacy natively. Yeah, and developers here importantly can focus on writing privacy apps without having to worry about writing specific circuits. I will admit, writing, and anyone that tells you otherwise is lying to you. Writing privacy-preserving applications is even nowadays non-trivial. And so here with the Anoma DOS, you can write the applications in Rust, so it's already nicer. But even then, it's not as easy as building the same EVM contract that the last 500 people have built before you, because you fundamentally have to change your mental model of how privacy-preserving applications actually work. Because as I was saying in the beginning, one of the big challenges is that all applications design historically was focused around a bunch of state in the middle, i.e. like, for example, Uniswap is an application that controls a bunch of global state on Ethereum. With privacy-preserving applications, you lose this sort of global, publicly readable state. And as a result, you really have to rethink on like how a lot of the interactivity, for example, on a user level works out. And generally speaking, this ends up, for example, for a trading application to work out in the sense that users end up having intents, i.e. like individual partial state transitions that they sign over, and then you have to take a bunch of these intents and combine them into a fully fledged transaction that's actually settleable. Because you don't, like with privacy-preserving applications, you don't have this global pool of state in the middle that you can just like update your state against. Yeah, use cases for this. I mean, payments networks, infrastructure for agentic payments. I think agentic payments, God, they will need privacy, or like, because you even have the other problem of like prompt injections. Like if I know how much money your agent has, because there's no human in the loop. I can start crafting very specific interactions with your agents in order to extract the most money possible. Like I really think the moment we want to go into automatic agentic payments, we're going to be in the realm of like, we need privacy, because otherwise everyone that uses those the agentic payment systems without privacy is just going to get. And I use exploited here not in the sense of like someone actively hacked you, but more they ran an algorithm to figure out what is the most amount of money they can humanly extract from you in that interaction. And so like I think the entire space of agentic payments is not going to work without privacy. You also have consumer dApps, for example, Anoma Pay and Anoma Swaps. Anoma Pay went live like 2 weeks ago, and it's now starting to roll out across the multi-chain. Also, you can use it for like the thing that I would like to use blockchains for, frankly speaking, which is like monthly payroll. And I don't know who in this room has done monthly payroll and has tried to use crypto. It is a horrific experience because you can't really do this because you have the choice between you go to Kraken and then you have 30 different addresses that you have to then pay from the Kraken account and use Kraken as your privacy system. Or the alternative is everyone else in the team figures out who else is getting paid and what amount of money and whether you're paying a vendor or not. Or you have to do the very complex thing where you have to keep rolling keys and it's just very annoying to use in reality. So Anoma Pay, for example, is one of the ideas here is that we will modify it slightly to also fit this payroll use case. And then BUIDL Enterprise, it's all about custom chains that are somewhat interoperable with the rest of the ecosystem, but at the same time are so configurable, for example, with regards to compliance, that enterprise actually wants to use them. For example, there's nothing saying that like the Hyundai chain shouldn't have a global read functionality that's private to Hyundai, but where they can read all the state, but for example, their customers can't. Yeah, so this is Anoma Pay, private payments made easy. If you want to check it out, it's cool, it's live. You can check it out at that URL. It just gives you quick private payments. Yeah, so yeah. Try Anoma Pay. You can also join the career chat. It's very fun. Like my hope is that we can also go to a model where, because this is the use case that I actually need, which is I just would like to be able to like paste an address and then I'd like paste that like and an amount and then that address receives the correct amount and I don't have to worry about whether I correctly did the setup correctly to not dox myself. So this is what Anoma Pay is really solving for. Yeah. So I think everyone that wanted to take a screenshot took one. And yeah, so thank you very much. This is Anoma. You can find the docs here. You can connect with me. Pretty much you can also message me on Telegram. My username and handle is always Adrian Brink. So yeah, thank you very much.